Hello everyone, today we'll talk about the problem patching array. We're given an array of numbers, and for an array of numbers we're interested in what numbers can be formed as a sum of the elements from the array. In particular, we want all the numbers in the range from 1 to n to be able to be formed in such a manner. So we can, let's say, take the first element, not take the second, not take the third, take the fourth, and then the sum of the first and fourth is some number. And we want to be able to create every number in the range 1 to n by numbers from our array. And to do that, we can add some numbers to the array. And we have to add the minimum numbers so that this whole range is covered. Every number can be expressed as a sum of some of the elements in the array. Now let's think about what would happen if no numbers were given as input. So we just had to cover the range from 1 to n, and we can choose any numbers we want. Well, the solution is quite obvious. We can just take the consecutive powers of 2. And now, for instance, this set of 5 powers will give us any number between 1 and 31 inclusive. So this is 32 minus 1. And it's actually quite easy to see how to create any number, because if we have a number in binary representation, then this number will be created exactly by here taking a 1, skipping a 2, skipping a 4, taking an 8, and taking a 16. Right, so we would do that if we weren't given any numbers. Now, one way to look at the process that we do, so for instance at this point we have those 5 powers of 2, we can create any number between 1 and 31 inclusive, because the sum of all the numbers is 31. And what should we add now to make that range larger? Well, we cannot add anything that is larger than 32, because then we still wouldn't be able to create 32. Because either, for instance, if we add, let's say, number 40 here, then either the sum will include 40 and then it will be greater or equal than 40, so that's bad, that's not 32, or it will not include it, and we know that in that case it can be at most 31. So since we have to include 32, we have to add a number that's 32 or smaller. So, is it a good idea to add a smaller number? Well, now's the time for you to think about that. And the answer, of course, is that we shouldn't add a number that's smaller than 32. That's because the set of numbers that we can create is actually very simple. If we can create here numbers between 1 and 31, we have to add something that's not greater than 32 to our set in order to create 32. And then we can create 32 by itself, and also 32 plus any number from this range, by just taking the corresponding set here. And now we can create up to 63. It can also be seen in this binary case that this is the best that we can do, because of the number of ways in which we can create, in which we can select elements from our set. There are only 2 to the I numbers of ways to select the elements, so if all of them have different sums, distinct sums, then yeah, this is the best we can do. So this is actually optimal. But that was a side note. Let's get back to our problem. So what can we say? Well, for instance, in our numbers, if we do not have a 1, then of course we have to add a 1. If we have a 1, then 1 can be created as a sum. And then we can just go through all the sums that can be created by some prefix of the elements in our array. So for instance, let's say that our array is 1, 3, and 10. So here we can create, with the first element, we can create the correct range from 1 to 1 inclusive. So what about 2? Well, since 2 is smaller than all the next elements, and we cannot create it, we have to be able to make it somehow. And we've shown previously that if we want to now make a 2, we should add a 2 to our array. So this is something we add. And now the sum that we can get is all the sums that were previously available, so only 1, plus the current value that we add. So now we can reach 3. Now we see a 3. What are the sums that we can reach now? Well, we can reach numbers from 1 to 3 on this prefix. And now we can add 3 to all of them, so we can reach numbers up to 6. Now, here is a 10. 10 is not equal to 7, right? Because 7 is the first number that we cannot create. So we have to be able to create a 7. We might as well just add a 7 here. Now we can reach 13. Now by adding a 10 onto it, we can create 23. And we can now keep on adding the next missing number until we reach n or something greater than n. So here we cannot create a 24, so we add a 24. And now we have here 47, the number that we can create. And this greedy approach is essentially the same thing that we've seen in the binary case. And this will be the approach that we use to solve this problem. So again, we just remember what is the next number that we cannot create. And for as long as this next number we cannot create is one of those in the range that we have to cover, we can either take the next number, because we can reach that number with what we have, so this is this condition. And in that case we can, to any sum that we have, add this number, so the next sum that we cannot create is great, it can now be increased by the number that we're looking at. Otherwise, we're missing the next number. And in that case, we can just add the number that we're missing, and as a result, the number that we're missing will be now double the old missing number, right? So for instance, because maybe it wasn't clear here, but you can see that this is exactly what we were doing at the beginning. So first, here we could create a 6, now we can create a 14. So the missing number was 7, and now the missing number is 14, so this is indeed twice that. The same thing happens here. For instance, here we have 23, so we cannot create a 24. So after adding 24, we cannot create, of course, a 48. So this is this doubling you can see also on what we've been thinking about. And at the end, of course, because we have to count every time we add a new element, we just return the number of times we did it.